solve systems of equations algebraically with substitution. This is lesson 8 in our note packet. Get your note packet ready. If you're not using a note packet, you're taking notes in your learning log. Get that title down. Get the learning target down. I can solve a system of equations using substitution. And get the definition of what is substitution down. Substitution is replacing a variable with a value or expression to solve for the other variable. All right, remember, at any time you can pause and rewind, but write everything down. So how do I solve a system with substitution? I've got some steps lined up for you. If you have the note packet, you already have these printed out. If you don't, you need to write them down. Step 1, set them equal using substitution. Step 2, combine variables on one side. Combine constants on the other side is step 3. Substitute solution to the original equation to find the other variable. And then step 5, write the ordered pair. This will make more sense as we go along, but you can go ahead and get those written down before we start with our first example. So our first example is written out for us. Y equals 2x plus 7 and y equals 4x minus 91. Okay, so that's our system. Now, if we go back to a previous lesson and think about what we can see, these are both in slope-intercept form. So that's great because we can see the slopes and we can see the y-intercepts. And what we already know about this is they have different slopes. Remember, you find the slopes in front of the x. So the first linear equation has a slope of 2, and the second one has a slope of 4. Different slopes, different y-intercepts as well. 0, 7, 0, negative 91. Those are way different. Different slopes, different y-intercepts. So we already know that there is just going to be one solution to this system. And it's just a good thing to kind of think through in your head. Remember when we did those types of solutions? Different slopes, different y-intercepts. So there is going to be one solution to this. Just kind of keep that in the back of your mind. Okay, so both are in slope-intercept form. Both say y equals. So we're going to take one of those y equals and substitute that expression in place of y in the other equation. So I'm going to take the second linear equation in our system and take that 4x minus 91, and I'm going to substitute it where y is because it says y equals 4x minus 91. So I can put that where y is. And what that's going to look like then is 4x minus 91 equals 2x plus 7. So that was step 1. I'm setting them equal using substitution. Taking what we say y is and putting it in place of y. All right, now I want variables on one side. So I have a 4x and a 2x. I'm going to take the smaller one, 2x, and 0 pair it. The 0 pair with 2x is a negative 2x. So I'm going to do negative 2x on both sides. Draw your wall. And always make sure you've made a 0 pair. Positive 2, negative 2. Yep, that does make 0. Okay. Do the math. On the left, work from left to right. 4x minus 2x is 2x. Now notice I'm not taking 2x away from 91. Those aren't like terms. 91 is a constant. Negative 2x is a variable term. So your 91 just falls down, as does the equal sign. We've 0 paired the x terms on the right, so all that's left is 7. All right, that was step 2. Now step 3, combine the constants on the other side. So we don't want everything on the same side. Constants are going to go to the right since the variables came to the left. To make a 0 pair with negative 91, that would be positive 91 on both sides. This is our 7th grade equation work really paying off here. Make sure you've made that 0 pair. You have a negative 91 and a positive 91. Yep, that does make 0. So on the left, all we have is our 2x. And on the right, we have a positive 7 and a positive 91. That would make a positive 98. All right, 2 times x equals 98. But we need to find for 1x. So we're going to divide by the coefficient of 2 on both sides. 2x divided by 2 makes your 1x. And 98 divided by 2, might have to do long division on this. 98 divided by 2, 49? 49. All right, so remember, I'm getting an ordered pair here, one solution for where these lines intersect. So make your ordered pair. You've got the x value. Substitute that in. Okay. Now, to find the y value, we're going to take what we got for x, and we're going to do more substitution. We're going to substitute that into one of the equations where x is. So I'm just going to take the top one. It doesn't matter, though. And I'm going to do y equals 2 times 49 plus 7. All right, 2 plus 49. Well, we just kind of did that. We did 98 divided by 2 to get 49. So then we know 2 times 49 is 98. And we have to do 98 plus 7 to then find y. 98 plus 7 is 105. So our y of our ordered pair is 105. Oop, losing my connection here. Hold on. Still working on it. Still thinking about it. There we go. All right, so now that I have that ordered pair, this is my point of intersection, right? This is where this system of equation would meet. If I graphed it, they would meet at 49, 105. To prove that this works, you would substitute these into both equations as follows. Let me show you. So in the first one, y equals 2x plus 7. We're saying y is 105 and x is 49. So it's like doing your check, right? Is the left side going to equal the right side? And it does. And then you would do that for the other equation in the system as well. Y equals 4x minus 91. Y is 105. X is 49. Four times 49. Oh my goodness. That would be a 6. 16, 17, 18, 19. 196 minus 91. That is 105. Okay, so the checks that we tried so hard to get you to as 7th graders really pay off as 8th graders because you can make sure that your point of intersection is correct. All right, let's look at another example. Same steps. If you have the notepad printed, you don't have to write them because they're there. If you don't have it printed, you can choose to write them or not. You can just look back at your previous page. But we're going to look at our system and we're going to follow the steps here. So y equals x minus 6 and y equals 3x. Thankfully, they're both in slope-intercept form. We can look at it again and notice that the slopes are different. The y-intercepts are also different. You might say, well, the second equation doesn't have a y-intercept. It's not written. It's 3x plus 0, so the origin is the y-intercept. So again, different slopes, different y-intercepts, one solution, okay? All right, we're going to do the same thing. They're both at y equals. So the second one's saying y equals 3x. So I'm going to take that 3x and pop it in for y in the first equation. And then I'm going to rewrite it as 3x equals x minus 6. Variables on one side. I have a 3x, and maybe you want to write the 1 in, a 1x. 1x is smaller, so I'm going to move it to the left. I'm going to 0 pair that 1x with a negative 1x. 3x and negative 1x make 2x. These are opposites, so they make 0. And then this is a negative 6. Don't lose that negative. Divide by the coefficient on both sides, and you get 1x equals negative 3. Remember, start your ordered pair. We found the x. Now we're going to find the y by taking x, and we're going to substitute it where x is, right? So y equals negative 3 minus 6. Integer math, negative 3 minus 6, that's a party. So you add them, and you keep that darn sign, so it's negative 9. And there's your ordered pair. And again, you check in both to make sure that it works out and makes both of those linear equations true. All right, our final example, you're going to notice our system. We've thrown you a curveball here. The first equation is in slope-intercept form. The second one, what form is that? Do you remember? I know a few of you out there remember. It is, drum roll, standard form. Remember, standard form was great for finding the x and y intercepts. Okay, so we're still going to play around with the different forms. It's totally fine. So we're going to continue with our idea of substitution, and we're going to take this first equation says what y equals 3x plus 8. So we're going to substitute that where y is. Let's see what that looks like. So we have 8x plus 4 times the quantity. Y is 3x plus 8 equals 12. This is algebra at my most favorite, right? You're getting these equations that are really big, and you're having to do all these properties that you learned, and it's all just coming together. It's so exciting. Okay, so speaking of properties, the 4, the coefficient of 4 outside that parenthesis is a distributive property. And that means that you're going to distribute the 4 to the 3x, and you're going to distribute the 4 to the positive 8. Distribution, right? All right, so we have 8x plus 12x, and 4 times 8 is 32, and it's positive 32 equals 12. All right, look at this. We have some like terms right next to each other. Combine them. We don't have to move from one side to the other. They're on the same side. So just do what the operator between them says and add them together. 8x plus 12x is 20x plus 32 equals 12. We've got ourselves to a two-step equation from all of that. I'm running out of room. Two-step equation, 0 pair the constant. We're going to subtract 32 from both sides. I'm going to have to go over here. Okay, so we're left with 20x, positive 32, negative 32, 0 pair equals, and then we have a positive 12 and a negative 32. So that's a battle. So we subtract them. That's 20, and negative 32 is a greater distance from 0, so we keep the negative. Now divide by the coefficient of 20, and you get x to be negative 1. Woo, that was a lot of work. A lot of algebra, a lot of fun. All right, now we're going to do the same thing to find y. We're going to substitute for x. And I'm going to use the one that's in slope-intercept form because it already says y equals. So it's less math. So I'm going to do 3x plus 8, and I'm going to substitute for my x. I got -1. Now I have a little bit of PEMDAS to do. 3 times -1 is -3, plus 8 is -5. So the point of intersection for this system is at -1, -5. And again, you would substitute that in to both equations in the system to check to make sure that it makes that system true. All right, bring it. We're going to practice.